In this lecture, we will see the layout of a OR and invert, that is OAI 21 gate, which consists of three inputs, that is A, B and C. So we have to open the terminal window by pressing Ctrl Alt and T, Ctrl Alt T, then type magic. Since it has three inputs, that is A, B and C, the OR part will be taken up by A and B, and the AND part will be taken up by C and the output of A or B. So this is the layout window. We will draw the layout by using the commands. So at first type grid in order to grid in, and after this you have to create the anvil. So type paint anvil. Now before drawing the p-will, we have to keep in mind the function is a plus b dot c. So when we have a plus operator, the NMOS will be in parallel and the PMOS will be in series. And when it's a plus b dot c, then the C input will be given in series for will be given in series in the case of the NMOS and in parallel for the case of PMOS. Now at first the hole can be given as PMOS, P diffusion layer. So select the point from here up to here. Then type paint P diffusion. Have to place shift set. Now we have the N diffusion layer or the NMOS. So we'll be doing this according to the twisted schematic diagram. So place the PMOS over here, the NMOS, then type paint and diff. Okay. So we do not need this part as of now. Okay, at first skip to gates. We need to get terminals. Okay, then type paint poly then type poly. After this you have to remove this portion, type erase. Okay, then type paint poly. Okay, now this is the source terminal, this is the source terminal. These two are connected to VDD. So type paint M1, then similarly over here type paint M1, then from here to here so this is the VDD layer. Similarly, you have the ground layer over here. Type paint M1, paint M1, if you want you can erase this part just for uniformity. Now very simple one, this is connected, this is ground. Mostly these are shorted, like this is source, this is the source. The two sources are connected to ground, and the two sources of here are connected to ground, and the is connected common drain is connected over here. So you have to undo this part. Okay, have to remove this part. Then type paint M1. So these two sources are connected to ground. Now this is the common drain of these two NMOS, which is connected to, let's say this is the drain terminal, or this is source terminal. Let's say this is source terminal. Then type paint M1. Similarly over here type paint M1, then connect it. Now this common drain is connected to the source of this NMOS, and from here, let's say this is the common drain point, or we can either make it as, let's remove this portion, let's say type erase. This is paint anvil. If you want, you can connect this to green just as to look uniform. That is, we have to be merged together, so two and merged together. Just for uniformity, ground it, paint M1. Similarly over here, type paint M1, then short these two, paint M1, paint M1. If you want to erase this portion, select the area, type erase. Okay, now you have to place the contacts. So this is your P diffusion layer. So type paint P diffusion contact, that is PDC. Here again type paint PDC. Type paint PDC. Paint PDC. Okay. Now this is the N diffusion layer. This is NDC. Paint NDC. Similarly over here, type paint NDC. Okay. Now then type, this is the N-well contact or the N diffusion contact, N substrate contact. Have another over here, NWC. Then this is the ground layer, paint PWC. paint PWC. Okay, now this is the layout. This is done. Now we have to do the labeling part. So this is paint poly. Paint poly. Now this is the output. So paint M1. Okay. So type label. This is VA. This is VB. VC. And this is the output VZ. Then we have VDD and ground. This is VDD. So type label VDD. This is ground. Now you can save this as Or and Invert 1. You want to find the DRC errors. There are no DRC errors. Then extract. The ext file is generated. Then extract to sim. Then extract to spice. Okay. Now after this, type irsim OAI1.sim. Now you want to watch VA, VB, VC and VZ. Enter D display. So all the values are X. Now if I type low value to VA, VB and VC, what will be the output before pressing? If these two are 0 0, then this is A, VA or VB, output will be 0, and VC, that is 0, then the total output will be 0. This is Or and Invert, then the output, final output will be 1. See, this is 0 0 1. Now if I give high value to VA and then press S, then the output will be 1 again, because these two are Or, that is 1. 1 and 0 is 0, so the output will be 1 again. If I give high value to VC, then I'll get VZ as 0, because these two output will be 1. This is 1, then the AND will be 1. see, the finally obtained output is 0. So if I want to see it in an analyzer, I'll type ANA, VA, VB, VC and VZ. So you can see this. If I want to pull it up, this is 0, 0, 0, output is 1, 1, 0, 0, output is 1, 1, 0, 1, the output is 1. This was waveform. Then exit. You want to see the spice file, then type VIOAI1.spice. This is MOSFET 1, DP FET WILS 12/4, all are 12/4. Similar, you have the area of diffusion, the same thing as we have seen earlier. If you want to see the layout again, then type magic OAI1.mag. So this will help you in loading the layout. So if you want to zoom in, then zoom in. You can see this is the layout of a OAI21, that is Or and Invert. This part is the Or part, this is the AND part, and the total output with invert. Close this. If you want to exit, type exit. Now let's see how to draw the layout of OAI21 gate without using the commands in Magic. So we have to open the terminal window by pressing Ctrl Alt and T. Then type Magic. Press enter. So here we will use the toolbar present in the layout window. So this is the layout window and this is the TK-Con window. So go to options. In order to load the toolbar window, click on toolbar. So all the layers like P diffusion and diffusion, the various contacts are all present over here. Now since we won't be using any commands, in order to grid in, we will type G in the keyboard. Then after this, we have to draw the NMOS and PMOS layers. So in order to draw the PMOS, you have to take the anvil. Okay. And then middle click on anvil. Similarly over here, middle click on anvil. You want to erase this part, then select the portion and then middle click. Click over here and then over here and then middle click on P diffusion layer. Then again middle click on P diffusion layer. Now of this same area, middle click on end division. Similarly over here, click, and then over here of the same area, middle click on end diffusion layer. Okay, now we have to connect the two PMOS and two NMOS gates, that is PMOS1, NMOS1 gate, PMOS2 and NMOS2 gates. So click, then middle click on poly. Similarly over here. Okay, if we want, we can just type undo. Middle click on poly. Again, we need some uniformity, so middle click, then over here, middle click on poly. Poly. Okay, now the gates have been shorted. Now this is A. The A and B are in one envelope P diffusion. This is C. So these sources of the two PMOS, they are connected to VDD. So middle click on M1, this and this. Then middle click on M1. Okay, then select from here to here. Then again middle click on M1. So this source is connected with this source. They're connected to VDD. Then now the sources of the two NMOS, they are also connected to ground. So select the area, then from here to here, then middle click on M1, from here to here, M1, then again M1. Undo, This should be connected over here. Then middle click on M1. Now you can remove this part, middle click outside. Okay, so these two sources are grounded. Now these two are source. This is common drain. The common drain is connected over here to this source. This is the source. So this drain then middle click, then middle click again, middle click on M1. Okay, now common drain is connected to this source. Now from middle click, from here to here, so if you want to remove this extra portion, select the area, middle click outside, same here. Okay, now these two are also connected. After this you have to place the contacts. So select the area. This is the PD contact or the PD fusion contact. Before that, this is the drain. This drain is also connected over here. So okay, now we have to place a contact over here. The PD contact, same over here, another PD contact. PD contact, and here we have the ND contact or the end diffusion contact. Similarly over here and over here. After drawing, save it as save OAI 2. Now we have some more contacts over here also. That is the N substrate contact here also. Then you can place the P substrate contact over here. P substrate contact. Okay, now after this, save it again and then go for labeling. For labeling, we have to label the VDD ground. Let's label VDD. Then label ground. This is A. So label VA. Label VB. VC. And then this is the output. This is label VZ. Now save it. After saving, find the DRC errors, if any, no errors. Then extract it. Extract to spice. Spice file extracted. Then extract to sim. The sim file is needed for the IR sim. After extracting the sim file, type is sim OAI2.sim. Then you have to keep a watch on VA, VB, VC and VZ. And plus D all have the X value. Then if I give low value to VA, VB and VC, what will be my output? If I see, if these two are 0, 0, output will be all, that is 0. These two are 0, then again AND output will be 0. Then the final output will be invert of 0, that is 1. See, VZ is 1. If I give high value to VB, then what will happen? These two are OR, that is 1. 1 and 0 is again 1. 1 and 0 is 0, the invert is again 1. If I give VC as 1, then my output will be 1. Why? 1 and 0 is 1. Low value of VC. Okay, I want high value of VC. Output will be 0. Why? 1 0 OR is 1. 1 1 AND is 1. The invert is 0. Now if you want to see the analyzer, then type ANA VA, VB, VC and VZ. Go to zoom and full. 0 0 0 output is 1. 0 1 0 output 1. 0 1 1 output is 0. Close it. One exit, type exit. If I want to see my file, then I'll type magic, then OAI2.mag in order to draw the, in order to load the layout. This is the final layout, and this is the right layout of OR and invert with using the toolbar. Now let's see how to draw the layout of a OR and invert gate from the untwisted schematic. So open the terminal window by pressing Ctrl Alt and T. Then type magic. We can do this with using commands or without using commands. So let's do this without using the commands, that is from the toolbar, because it's quite easier and quicker. So in order to grid in, press G. Okay, then go to options, then toolbar. When we say it's untwisted form, so this is the PMOS one. So NVEL. Then in series we have PMOS 2, and then in parallel we have PMOS 3. Okay, now click over here, then click over here, then middle click on P diffusion, middle click on P diffusion, P diffusion. So these two are in series, this is in parallel, the PMOS, and just in reverse we have the NMOS. Let's place the C first. Okay, now this is in parallel, this is in series with the two NMOS in parallel, the two NMOS in parallel, NMOS 1, this is NMOS 2. Now that is N diffusion layer. After this, just zoom out and see. This is A, B, C. This is A, B and C. We could have done the reverse also. This can be A, B and C. Okay. Now we have to join by poly layer. Then middle click on poly. This is A and here is A. Now this is B. Now before that we can connect C. Now let's make a rough analysis. This two will be connected. Okay, before connecting the gates, connect these two. Middle click on M1. Okay, these two are connected to gate. This is the VDD. These two are connected this is drain. This is the source of another this PMOS. Okay, now these two drains are connected with click. Middle click on M1. Middle click on M1. Okay, now these three drains are shorted. Now this is a source terminal that is connected with these two drain terminals. Again, these two drain terminals are shorted. Undo. Okay. Okay. Now you can see the space for drawing this. Or you can take this from here also. This is B, this is B, this is C, this is C. Okay. 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 This is connected with this. And this has to be connected with this. So you can do one thing. Zoom it. This is connected over here. And these two are grounded. Okay. Now this is ground. So let's place the contacts. You can see the if we draw from the untwisted schematic, then how the layout looks. Now this is VDD, so this is a PD contact. Here also we have the PD contact, PD contact, PD contact over here also. Okay, after placing the PD contacts, we have to place the ND contact. So middle click on ND contact, then over here also the ND contact, ND contact. Okay, now after placing the diffusion contacts, we have to place the substrate contacts, that is the N substrate contact and substrate contact, and over here we have to place the P substrate contacts. After this, let's label this as ground, label ground. Then before that, just save it as OAI 3. Then after labeling ground, label the VCC, label VCC, that is VDD. Then after labeling the VDD, this is the input A, so type label VA, this is A and this is B. So okay, let's undo. Label VB, and then this is VC. After labeling VA, VB, VC, we have to label the output. This is the output. So type label VZ. Now save. So you can see how clumsy the circuit becomes. Then type DRC find. There are no errors. Then extract ext file generated. Extract to sim file generated. Then extract to spice. The spice file is also generated. Now after generating the sim file, type sim oai3.sim. Keep a watch on VA, VB, VC and VZ. Press D. All the values are given as X. If I give low values to VA, VB and VC, then my output will be 1. Since VA plus VB is 0, VA plus VC into VA plus VB into VC is again 0, and the invert is 1. If I give high value to VA, the output will remain as 1. When I give high value to VC, the output becomes 0. Why? Since VA plus VB will be 1, VA plus VB into VC will be 1, so the invert is 0. If I want to see the analyzer, then type ANA, VA, VB, VC and VZ. Zoom full. So when it's 0, 0, 0, output will be 0 and its invert is 1. When 1, 0, 0, output will be 0. Again the invert will be 1. When 1, 0, 1, the output will be 1 whose invert is 0. Now type exit when you want to exit from here. If I type magic OAI 3.mag, then you can see the layout of this or and invert. Okay, so this is the layout of OAI 21. If you want to see the spice file, then type exit, then type vi OAI 3.spice. Now see, it's written spice3 file created from OAI3.ext technology SCMOS. The scale is 1U. We have 1, 2, 3, 4, 5, 6 MOSFETs, 3 PMOS, 3 NMOS. You can see the first PMOS has different W by L ratio. Why? Because the width was 9 as same as the others and the length was 3. It was shorter. It was the shorter one. And these two pipets are of width 9 and length 4. Why? If you remember, then this is the pipet. These are the pipets where they were combined in one. They were combined in one. These are the NPETs. Similarly, here in the case of NPET, just the opposite has happened. In the single NPET, the width is 9, length is 4, and the combined one has width 9 and length as 3. Similarly, we have calculated the area of diffusion. It's less. Over here, it's 243. It's quite less compared to the AND or invert. Perimeter of diffusion is also less. Similarly, we can compare the other parameters. Now type : WQ in order to exit.